So this is a session where we are going to talk about machinery. How do we come up with low-cost machinery that are appropriate in terms of the functionality, what they do, appropriate in terms of how they are priced, appropriate in terms of how long they last, in terms of ability to maintain, service, all the works. For machinery that are used in processing and packaging. And I must say I have built quite a few machinery in different contexts, which probably will tick all these check marks of being low cost, etc., etc. But I am a newcomer to this area of food processing. But fortunately, we have two very good panelists who have done some work in this area to set the context. I don't want this to become a lecture event. I want actually to draw you all out into coming up with defining specific problems that can be addressed and even going halfway towards what the roadmap towards a solution will be. But to set the context, what is the kind of problem we set out to solve? What kind of difficulties do we face along the way? And finally, when we do succeed in coming up with a solution, there will still be some limitations, room for improvement. So in that sense, it will be good to look at a couple of case studies of what we did, what worked, what didn't work. And in that context, I'm requesting my two panelists to briefly outline some things that they have done in this area and give us a framework within which we can then approach the fresh set of problems that you will all come up with. Over to Dr. Balakrishnan from TNAU, and he'll be followed by Dr. Abhijit Deshpande from IIT Madras.
So good evening to one and all present here. So I am heading the Department of Food Process Engineering at TNAU, Coimbatore. So the main mandate of our department is to develop on-farm post-harvest processing equipments to address the farmers' problem and also address the post-harvest issues, both on the field and off the field. So we are working for the past almost 30 plus years. And we have developed so far so many post-harvest equipments for both the durable commodities like paddy, that is cereal, pulses and oil seeds, and also for the perishable commodities like banana, tomato and other perishable commodities. So I will show some of the equipments that we have developed for the perishable commodities. First one is, as I said earlier, we have developed a banana cable conveyor to minimize the handling losses. So we can visualize the video.
Bananas are the major fruit crop being cultivated extensively in India. In Tamil Nadu, bananas are grown in an area of 1 lakh hectares annually. Technological interventions of the Tamil Nadu Agriculture University, Department of Horticulture, Government of Tamil Nadu and ICR National Center for Banana have combinedly helped the growers of Theni district to venture into intensive and high-tech cultivation of banana, incorporating scientific methodologies. Usage of tissue culture plants, adoption of drip fertigation technology and scientific post-harvest practices from every stage of cultivation, harvest, post-harvest handling and pack-house operations to improve the shelf life have helped the growers to reap huge profits. During 2017 and 18, the Tamil Nadu Agriculture University took up a collaborative program along with Tamil Nadu Banana Growers Federation, Port Trust of Trieste of Italy and the University of Udine, Italy, to design and develop a cable conveyor system for transporting harvested bunches to farm-laid pack house so as to avoid bruising on the fruits during the handling and enhance the opportunities for export of banana from Tamil Nadu to European markets. The design fabricated by TNAU was tested at Gudalur of Theni district. Due care was given during pre-harvest phase of tissue culture banana plants. Soon after the emergence, bunches were protected by covering with sleeves and tagged for observation on maturity. Bunches attaining 75 to 80% maturity were carefully harvested and hooked onto the banana conveyor fabricated for testing. The banana conveyor designed by TNAU was found to be fully met out the requirements of transport of field-grown bananas. On unloading the banana bunches from the cable conveyor, the hands were separated, washed free of debris adhering to its surface, graded, and packed in carton boxes. A trial consignment with 400 kg of samples were sent by air shipment to University of Udine, Italy for testing, and it was found that the bananas could ripen normally even after 40 days in cold storage and at superior shelf life compared to the conventional harvest and handling methods. The cable-way conveyor facilitates to reduce the post-harvest loss in handling the bunches from the farm to pack house and also avoids human handling and physical drudgery. It is suitable for large farms and also for collective small holdings in transporting the farm inputs and to bring out the produce. With the assistance of ICR, National Research Center for Banana, a simulation trial has been undertaken to standardize the shipping protocol of bananas from India to Europe. The newly designed and fabricated cable conveyor developed by TNAU and the improved post-harvest practices have paved way for opening up professional banana exports from Tamil Nadu and triggered the business opportunities of Indian-grown bananas, namely Grand 9, Red Banana, Neipuvan and Nendran to European continent and other long-distance destinations across the globe.
So what you have seen is the granite banana. So this is also a
I think we should only focus on food processing machinery, what can be done, not on other things. I'm sorry to interrupt, but we should process on food processing machinery. How do you design food processing machinery, low cost, and make the whole thing viable? We are not going to discuss all other things. Okay? Yeah. Keep that discussion focused. Sure. Yeah.
So I will show the set of post-harvest machineries or food processing machineries which will reduce the human drudgery and also improve the losses and also reduce the losses. Next. 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 So this is one of the cassava chipper. So this is meant for converting into chips form. So we have developed at a cost of around 10,000 rupees. It is mostly suitable for the cassava for converting into chips. The capacity is around 250 to 300 kg per hour. Next. So this is another chili seed extractor. It is mainly for, due to the pungent nature of the chili, we cannot able to extract the seeds from the chilies. So by means of this machinery, we can able to separate the seeds from the chili. So we can reduce the pungent nature of the chili during the extraction of seeds. So the cost of the machine is 10,000, the capacity is 50 kg per hour. Next. So these are all on-farm operations, so it can be performed after the harvest. So next is a tomato seed extractor. So this is also another important equipment for separating the seeds, mainly for seed purpose. So it involves human drudgery in separating the seeds from the tomato. So we have developed this tomato seed extractor. The cost of the machine is 30,000 rupees and the capacity is 200 kg per hour. So by this way, we can able to minimize the quantity of water required for the extraction of the seeds from the tomatoes. Next. So next one is the brinjal seed extractor. Similar to the tomato seed extractor, we can also separate the seeds from the brinjal. The cost of the machine is 35,000 rupees and the capacity is 120 kg per hour. So here also we can minimize the quantity of water required for the extraction of the seeds. Next. So is another turmeric boiler. It is the problem in the during the turmeric post-harvest processing. So by this way, we can able to improve the quality of the turmeric rhizomes by means of this boiler.
If I can ask a question. Yes. Now, are these being manufactured by somebody, sold at scale?
It is developed by our Department of Food Process Engineering, Tamil Nadu Agriculture University.
Okay, but how do we make sure it reaches the largest number of people?
So actually, this particular turmeric boiler, it is given to the Spices Board for subsidy to the turmeric growers.
Okay, but the different machinery that you have developed,
Yes, sir.
how does it go from university to the targeted end user?
So actually, we have given to the agriculture engineering department for inclusion of subsidy to the farmers.
Okay, but somebody has to manufacture it.
Yeah, we have
service
given
it.
license to the manufacturers.
Okay. So
We
are
have given
these-
the license.
Okay, so these are now being made in some volumes and used.
Yes, sir. Yes, sir. Turmeric boiler. This is actually subsidy. It was included in the subsidy for the turmeric growers in the spices board.
Okay, but is the issue in translating from the university to the end user only one of subsidy, or are there any other
So
issues?
otherwise, we can have a directorate of agribusiness development in our university. So actually, it is the commercialization is done by the directorate of ABD. So they are doing that business.
Okay,
So to a large scale, the commercialization can be done through the directorate of ABD. So Dr. Sundareswaran is from ABD, Dr. Murali. So once it is released from our
see,
university,
what has been my experience in general is that a lot of good ideas come up in lab.
Sir,
but
actually, we
translating
have-
that into large numbers of users who are happy with using the machine and gaining profitably from it, there are a lot of steps along the way which normally are not adequately addressed.
Sir, in TNAU, we have technology commercialization wing under the Directorate of Agribusiness Development. Whatever the technologies evolved from research from various departments will be given to the, the details will be given to the ABD. ABD in turn will invite people for, providing license, both on exclusive basis or non-exclusive basis, with license fee, with royalty and all these things. There are set procedures. So based on that, we are giving license to the manufacturers, those who are interested. Even sometimes for one machinery, 2-3 manufacturers can also come. That is based on the non-exclusive method we are giving. In turn, they are producing, manufacturing and supplying to the departments and farmers. So this is the process, sir. The university is not directly manufacturing any machineries or product and supplying it to the farmers. So it will identify and develop the technology. Through, again, that licensee only, we are popularizing the machines.
they have to pay the licensing fee for getting the
And
technology.
how do we ensure that quality and other things are maintained or support is provided? Supposing I'm a farmer and I buy some equipment and I find it's defective, then what is it? Do I come to TNAU to
So
resolve the
we
issue?
will
Or how do
provide
I-
all the technical support, sir.
But it's been manufactured by
But
somebody.
it is the duty of the manufacturer to
Sir,
give
for
the
which
technical
we have MOU between manufacturer and university. What is the problem? What is the issues to be undertaken by the manufacturer, and what are the issues to be solved by the university? Based on the MOU only we are giving, sir. For example, manufacturing defect, university will not take any responsibility. Like that, we draft the MOU. Based on the MOU, we will operate.
So the technical support will be provided by the university, the concerned department.
Yes, sir. Because they are, once they want to get a license, they have to become a member of the consortia. So once they become a member, they have access throughout the year. At any time, they can access being a member. University is also liable to, meet their requirement and provide any technology and their doubt and all these things. Suppose if they want any improvement over it based on their experience, that also by payment, additional payment and all these things, university will take up additional research to improve the protocol or technology and all these things. So once the manufacturer come to the consortia, join as a consortia member, then they will be in touch always. So every problem, field problem will be solved.
Okay.
Yes, sir.
Next.
Would you like to comment something on this?
Okay, next. Thank you. So, next. So this is another important equipment for thresher for black pepper. So it is also involving a human registry for separating the berries from the pepper spikes. So we have developed both the hand operator and the power operator thresher for black pepper. Next. So this is the power operator thresher for black pepper. So we have to separate the berries from the spike. So the cost is 35,000 and the capacity 320 kg per. So in a conventional practice, they are going by the trampling by feet, so which causes more breakage. So that can be reduced by this equipment. So we can minimize the breakage of pepper berries. So also the quality will be improved. Next. So this is meant for white pepper production. So we're having a huge market in the Western and European countries. So we have developed a on-farm white pepper peeler. So we can produce the white pepper out of this equipment. Next. Next. So also we have developed the fluidized bed dryer for mushroom. So in order to increase the shelf life of mushroom, so by removing the moisture from the mushroom, we can improve the shelf life. So the cost is 30,000 rupees, and we can go for 6 kg per batch of mushroom. So once we convert it into dried form, it can be used for several purposes. Next. And then a continuous seed removing machine for anola, that is amla fruit. So this is because the removal of the seed from the anola fruit is very tedious and human drudgery. So we have developed this continuous seed remover for anola. The cost of the equipment is 50,000 rupees. The capacity is 100 kg per hour. And we can able to separate seeds from the 3,000 kg of 3,000 fruits per hour. Next. So arecanut dehusker. So we have to separate the husk from the arecanut. Next. So these are the another one is for tomato, we have developed a tomato pulper. For once it is converted into pulp, that can be converted into a paste. So by this, during the surplus production, we can convert the tomato into tomato paste by means of converting into pulp. Next. So this is another, we have also developed a packaging of tomato in corrugated boxes. So once, when the price is more, we can go for these corrugated boxes in order to get in order to improve the shelf life of the tomatoes. Next. So these are some of the machineries we have developed from our department. So apart from this, we have developed a lot of machineries for durables as well as perishable commodities. Thank you.
Thank you. Thank you very much. Do we have...
Hello, good afternoon. I am Abhijit Deshpande from IIT Madras. And what I have here to sort of talk about is just one case study and then immediately some broader sets of thoughts for us to think about in terms of low-cost machinery. So we basically had a demand for this, we can go to the next slide, yeah, paddy thresher for a small landholding farmer, 2 to 4 acres. It should be able to provide threshing for indigenous varieties of rice, and it should be flexible for dry wet operation. And it should be generally integrable with general practices of organic farming, sustainable, still have some labor integrated and not complete removal of community basis. And of course, one could think of solutions, paddy should be grown in very large farms. Why not grow varieties which can be harvested easily, or move away from labor requirements? But the statements are on the right side. So given that context, we said we will do a small-scale paddy thresher. So this is the machine which has been developed, and it's a tractor-operated machine. Next slide. And basically successfully tested for various varieties. Wastage is pretty less. It's quite successful because there can be 20% wastage if you do a combined harvester and thresher kind of things. But then the failures of some of these initiatives can end up being, and the first question, especially coming from an academic institution, and Professor Junjunwala will always sort of question RUTAG model based on this, is really, did you do a case study before? I mean, who needs it and what's the business case for such a machine? Not very clear. Fabrication cost is about 1 lakh. If you say that it's going to be produced somewhere else and delivered somewhere else, you have to add certain things. Then another question which was posed in the morning is, can it be a low-cost machine? So then the drum which is used, can it be a drum which is already available? So can you start doing frugal engineering to start replacing things which are low cost? So some of that is again a challenge to reduce cost. And then demand immediately comes from the farmer that yes, thresher is working fine and I am surviving last 2 years. One of the farmers which is using says is, because of the thresher that we provided, but now harvester is also needed on this scale, small scale. So it becomes useful if both of these are provided. And minor adaptation, for example, if a blower is given, then it becomes far more useful. So these are kinds of small things which needs to be added on. And blower is not something which needs to be designed, it needs to be added on. Or many times in operation, for example, in one of the cases I saw, it was being operated and partway they just left it and they went back to sort of manual threshing because the belt was loose. And the users do not have the capacity to do this small amount of tinkering to, just adjust the belt. So there are these kind of operational issues or adaptation issues when such small scale machinery are actually being used in the field. And if we are thinking of a village processing unit, I see no reason why such issues may not be again crop up. So just to now look at, what was sort of clearly stated that, we need to do processing and packaging in village itself. The goal is zero wastage and not necessarily promotion of some variety because it is correct size or correct shape or correct processing for McDonald's or whatever. And it has to be frugal machinery. And of course, we're saying clearly no, that it's not going to be very large scale aggregation. We cannot produce some crop variety and it cannot be a top of the line machinery from, like Professor Junjunwala mentioned, from Korea or Japan. So given this sort of overall context, one of the things that I was wondering about in the next slide is the engineering challenge post. I mean, we are still talking about that university develops it or somebody else develops it, then it gets fabricated. But the way I see it, the major challenge post design fabrication delivery is because of this specific context that we need multiple crops to be processed, we need different types of tomato to be processed. So we need design modifications, local adaptations, tinkering from one batch to move, as you move to the other. We also need some significant capacity at the local scale in terms of fabricators to do some of this. Vis-a-vis, some input can come from outside, but we need a good balance. What is that balance? I'm not sure, but I feel there is a balance needed. So given this context, one of the thoughts that I had was related to, we are talking about FPO, we are talking about a local franchisee, these two set in village, and then the FMCG startup, which consists of all of us. I wonder whether there is a space for a design fabrication aggregator also, who can carry forward designs from one location to the other, who can document various versions of designs and have them available and also help locally fabricate them. So that the village processing unit that we are thinking about can become a more sort of real possibility. So that's a thought I had. And towards this, we have done some work. So the next slide, I'll close with this. So we are trying to develop a platform. This is still a pilot stage, which is basically a platform which tries to sort of look at this space where fabricators, designers, and users can interact. This is basically YouTube++. In the sense, in YouTube, you can see that people advertise their products from all over the country. And there is always a statement saying, can I buy it? This is very good. You have done it for wheat. I want to do it for rice. So all these kind of questions. So can we have a platform where such a, exchange of designs and fabrication can happen? And so revenue model here could be per design that is supplied, quality of assurance that is guaranteed because of this aggregator being involved. And can we assure quality at different locations? And also some revenue based on subscription to this kind of a platform. So this is a thought that I have, and I'll be happy to answer any questions related to this or take part in further discussions.
Thank you, Dr. Abhijit. So in the context of all the things that we have discussed about, particularly about tomato and banana, and all of you are the people who are on the field, some of you are, of course, academics, some of you are in the startup or in the business of trading in it, and you all know it much. You know those crops much better than I do or any of us do. I want you to come up with what you think are the important gaps possibly that you see in terms of machinery for processing of these crops? Where do you think the challenges are? The challenges could be in terms of how expensive they are or how difficult they are to maintain, or the scale at which these machines are available, all kinds of things. It will be good if we could have a quick brainstorm, maybe write down the important gaps that are there and see what can be a roadmap for addressing those. Anybody, feel free to. Yeah. Yeah, you can. Yeah.
Good afternoon, sir. So, I am Selvan from Perambalur district. So, I throw this question to experts in agri, from IIT and the TNAU in engineering department. So, we started a startup based out of with the basic commodity as a small onions. Small onions, we have two process. Once, small onion will be cultivated with the top and the tail. So then what we do, we bring it to a place. In that place, we used to use manpower to cut the top and tail, and we valued that product. There are machineries available to peel these small onions, and we sell to the restaurants in South India. So in 2017, the cost of cutting the top and tail was 50 paise. The small onion price was around 10 to 20. The cost of that process is around 5%. So it's negligible. But currently the small onion price is 20 to 30. But the manpower scarcity now is it created 4 to 5 rupees. Almost 20%, 25% we are paying for the manpower to primarily process that small onion. So till now there are multiple institutes trying to bring out a machinery for that, just to cut the top and tail of that small onion. Still now there is no viable product available. We are also searching out in various institutes kind of thing. If there is a solution, the thing is the manpower is not available there.
Agreed. Just write down. Just a bullet point. You have a pen or something? Okay.
The cost of commodity
Fine.
increased by 100%, but the cost, manpower cost increased by 400% in these 5 years.
I get it. Yeah. Any other? Yeah.
See, we used to buy maize from farmers during the rainy season. When they cut the maize, the moisture used to be in the range of 22 to 26% moisture, especially in the areas of Kallakurichi, Ulundurpettai, those areas during December and all of that. But maize is bought by largely the poultry farms and other, kind of feed, this thing. They need it at 13 to 14% moisture.
Okay.
Farmers don't have drying facilities, and during rainy seasons, there's no way. So something today, maize is at 2,320 rupees per quintal. When it is at 26% moisture, this is sold at maybe 600 to 700 rupees per quintal. And you can't keep it at home, so kind of everybody sells.
When you reduce the moisture, the rate goes up, is it?
Yeah, so because it will get moist fungus and all of that,
Okay.
so there is no affordable solution at a farmer level which could be used. And if the additional cost that you incur should compensate for the gain that you get from this thing. And there is lots of sensitivities about you should not lose the color. It should be still looking at golden yellow. Because when you put into a burner or something, if it can become blackish and all that, then the market value goes down, stuff like that. So lots of farmers were asking for, is there something?
When you say farmer scale, what is typically it will be 100 kilograms a day, or what is the kind of throughput?
2 to 3 ton per farmer.
2 to 3 tons.
And there are, if it is farmer producer companies that some applications can be done, it's in the range of 700 to 1,000 farmers. So, kind of roughly about 1,000, 2,000 metric ton, 3,000 metric ton.
Spread over how many days?
Spread over 10 to 50, maybe 5 to 6 kilometers.
So how many days will it be processed?
It's typically the harvesting window is between 30 to 40 days. It will be cut and then it has to be sold.
So about 3,000 tons over 30 days.
Yeah.
Nominally. So write that down. Interesting.
Can I answer for his question, sir?
Yeah.
Sir, have you visited Rasi seeds near Kallakurichi? Because you are talking about the Kallakurichi area. Yeah. So the Rasi seeds are they are procuring huge quantity from the farmers for seed purpose. They have installed a very big unit there at Kallakurichi itself. A fresh harvested with high moist cobs they are procuring and directly going for a drying, machine drying. For that they have some kind of machineries available with them. So after drying to 13 to 14%, then they are going for shelling, then for processing and all these things. So that is very good model. Very good model, sir. But it's not their own technology. They have purchased from somewhere. I think it is from Ludhiana. Somewhere they got and erected the machineries. It is working very well. We often take our students as a field visit to that factory. So it's very good. You can visit to Kallakurichi unit by getting appointment from Rajesh.
Say there is a demo unit or whatever. Kallakurichi.
Thank you.
Okay. Good. Any other areas of food processing where we find a gap for value addition, preserving through machinery? Yeah.
Within the tomato itself, I had one question. I mean, what is the scale of village processing unit that one should target? I mean, the machinery, how many kgs per hour, how many, or do you need, let's say, 3 options? I mean, it's what are our thoughts on that?
I guess that will depend upon the acreage that's there in the village. Okay. That's how many acres? So speak.
So for 1 acre, we can take a yield of 10 tons of tomato. And each FPO will have around 20 to 30 farmers, sir, linked. 20 to 30 farmers.
So if it is about 100 farmers and each farmer would have about 5 acres? Much less.
Sir, that may vary, depends upon the village to village, sir, because
Fine.
in some villages their main crop
So
may be tomato.
Just to answer this question, order
yes,
of magnitude, I'll say 500 into
In other
2,000 acres into 10 tons. So 10,000 tons. And what is the yield duration? It will be over a period of 1 month.
Five.
Minimum 10 tons per acre is normal, sir. Minimum.
Normal average yield.
Yes.
In
What is the duration?
5 months.
Approximately 4 months total crop in
I'm not talking about the crop duration. Picking.
picking. Picking it will take 30 plus
30 to 40 days, sir.
30 to 40 days. Okay. So 1,000 acres into 10 tons per acre is what you're saying. So 10,000 tons across a 30-40 day interval.
You know, the only, all these calculations for normal operations, but the goal that we have is when there is a sudden glut and we are going to get huge quantities in just 1 day or 2 days. So I think we have to think of the processing unit to be able to process such quantities. So that's really the calculation.
For that
What
we
is
need,
our expectation of produce arriving in those kind of situations?
sir, for this we need to definitely take up benchmark survey of that particular area, because that may differ place to place. Like when you set up a sugarcane crushing factory, they are doing it all analysis and all these things, how much area can be grown under tomato, how much area can be grown under other crop, if farmers can replace their crop,
I
existing
agree.
crop and all these
To
things.
get very precise
now
data,
we
we
cannot
need to survey.
decide the
But we
size
need-
and these things.
Yeah, we just need to have a indicative scale of what the nature of the problem
Yes,
is. Yeah.
Sir, when you were asking about the gaps that were in the technology, I do feel that our main focus, for example, if we take a plant, we are just focusing on the main fruit, right? So there are also other parts which can be monetized. The technology is now presently focusing on the main fruit. For example, we are talking about the case of tomato, but not the other parts. For example, we can make the other parts to make biofuels, or we can make it, we can use it for incineration plants to generate electricity. So that is where I see the skill gap. Sorry, not the skill gap, sorry. I see the gap, basically. So if we can focus on those technologies, it would be a supplemental income for the farmers as well. So that is my point.
Okay, would you all agree? I don't know enough about the tomato plant to know whether
No.
there are supplementary streams of income.
Even I'm not aware, sir. I'm a just psychology student. I'm just
Okay.
giving some inputs as far as I know. Like.
Banana, of course, and it's all being monetized. Nothing is being wasted too.
Yeah, my core concept is like our focus is mainly on a part which is just 20% of the plant, right? There are rest 80% of a plant.
Sure, sure.
Why we can't monetize that, which can be more useful? That is my point of view.
Yeah, yeah. So what other areas of gaps do we see? In fact,
Like that, earlier it was the problem. Actually, in banana growing area, after harvest of bunches, the remnants, remaining plant disposal itself be a problem. For that, we have to spend 10,000 rupees to remove all plant material and all these things out of our field for next cultivation. So now, because of this particular technology, now the people are coming and taking the product, waste banana plant after harvest for industries. So likewise, we have to integrate everything. That is called green farming. All the products coming from farm should be again utilized without any wastage. So like that we can use it. In tomato, after extracting everything, the waste material and pulp and all these things can be used for composting material or can be used as manures like that.
Sir, but I do feel a difference here because the case for tomato is different for the case for banana. Because
Definitely. Each product, each commodity, different case.
traditionally we have.
We need to develop different industries and co-generation. That's called co-generation of wood and
Sure.
wood
Yeah.
and fuel like that.
I'll give. Someone had a question.
Here's a word.
Sir, this is more of a question. So in case of tomato products, retort packaging is best, we have found, because it doesn't require any preservative added externally. However, the retort packaging machinery is very expensive. So if the experts could give us an insight on what makes it expensive, which are the components and which are the components we could work on. So a light on retort packaging could be helpful from the experts.
But what is the purpose of doing that packaging? It extends the shelf life or what?
Yes, without an addition of any external preservatives.
Okay,
Yeah.
fine.
Apart from the packaging, we have a lot of product right now in the market. Like for example, in US they are selling it as fresh stick. Fresh stick means small sticker. We at TNAU we have developed a nano stickers. Small price tag stickers, in any fruit you can find that product sticker, small sticker, which will say about the price and product nature. So like that, in that sticker, we have some, mechanism to prevent or prolong the ripening process. The ripening process is mainly due to the index production of ethylene. So once we stop the ethylene production, as long as we stop the ethylene production, the ripening process will not take place. So to curtail or prevent the ethylene process, we are having the sticker, nano stickers and other stickers available in the market. Those stickers, if we stick on the fruit, we can extend the shelf life for more than 15 days to 1 month. So that is there available, already available in the market.
Okay.
Yes, sir. Like that, The pod lab, one laboratory, one startup, I think one startup, they have started, very excellent startup, pod lab. They have some kind of small pouches. We have silica gel pouches to absorb moisture, we are putting in leather products. When we purchase leather products, we used to find small pouch which contains silica gel to absorb moisture. Like that, they have pod lab. It's a small pouch. If you put it in any container or any package inside, all the fresh fruits will be kept fresh, even for vegetables also, without any spoilage and without decay. So that technology they have patented and they have started. One startup they have started. Any product. If you put a small pot and that small package in any container, it can be, the shelf life can be prolonged. Likewise, it is available, it is open for students also. This is the very good area for your research, in future research. So not only the packaging and all these things, you can go for exploring what is the mechanism involved in ripening process and how to prevent it and all these things. So you can do work on that also.
Sir.
So, Dr. Abhijit.
Yeah, I just wanted to also throw open one more sort of thought, which is related. We're talking about low-cost machinery, but in the end, we are doing a process here. We are doing, extraction, pulping. So as a chemical engineer, I would say there is the elements of process engineering here, which needs to sort of be incorporated, rather than just thinking in purely machinery terms. We need sensing, we need quality control from that point of view. Materials itself, we have to sense whether the puree that is being produced has the appropriate quality and things like that. Other thought that I have, this is especially based on what Professor Junjunwala said in the morning, that can same machine do multiple things. So we used to have a company called Garda Chemicals, and in 80s, it prided upon the fact that it has a chemical factory, but it has no products, no set products. So depending on the demand and the business, it will make a chemical and do business. It specifically called itself a research-based chemical company. So in effect, this is what we are expecting the village processing unit to be very flexible, to be very quick on the feet, to keep on processing different types of foods for different purposes. So that's a thought.
Sir, I have one question. Because this concept has to be run for 365 days for the different products. So machinery, when have been bought, is a asset, and upfront it takes a upfront cost. So there are different machinery for different products. So if we are gonna run this concept for 365 days, that gonna be not very viable, or if there exist any technology or machinery which can able to adapt with the different types of fruits, different types of vegetables to produce a simple or the product, that will be more beneficial, or that gonna be do the things. Because if 365 days, there are different products and there are different machinery that
Yeah, I think what you're saying connects up with what Dr. Abhijit said just now, that we should think of machines not as individual entities performing one function, but we should think of them more as platforms which can be configured for different functions, which are allied to each other, and by changing, modifying, or replacing some subsystems, the same platform can do different functions. So I could, in one season, process tomato, in another season I'll process something else, a variety of things. A typical example is a tractor. Tractor is a multi-utility vehicle. At different phases of the agricultural journey, through different attachments, it can do different functions. So multifunctional machinery to improve the capacity utilization. That's really the idea. Okay?
Sir, do we have any machinery for removing the endosperm from the palm tender fruit endosperm? Nungu.
Okay.
Because it's very difficult to remove it from the endosperm.
Okay.
And also the peeling of the outer part.
So you talked about multi-utility. It's not like the other idea is it's not like making different products in one machine. Like you said, no, one machine can use all the work like grading, packing, production oriented. So if that is the case, now the cost will be very less and the time utilization also will be very less, and one small rural entrepreneur can utilize that machine and produce more.
Correct. Yeah, that's what I meant. So if you have a utility machine, just like a tractor for example, with different attachments we can do different things. So it can be reconfigured for different end users. Yeah.
I think for doing this, we need to delineate the area in which what all the crops is being grown. Okay, so based on that, we have to design. So what sort of the processing products we can combine. First, we have to delineate. Then only we can decide. So what will be the processing happen in the particular village processing unit? It will be different from village to village. So in the nearby areas, what are the crops grown? That is the first step we have to identify. Then we have to think over it, what sort of processing can be combined using the particular machinery. That is easy, I think so. If we are going from the back, then it is very difficult. The first step we have to delineate what are the crops and what are the processing methodology can be adopted using the same machinery. That has to be planned properly in the beginning. Then only it will be feasible.
Sure, I agree with you. Yeah.
Yeah, the platform that was mentioned by Dr. Kannan, that needs to be specified as to what all its capabilities will be.
Any other inputs?
This is more a query. We spoke a lot about vacuum packaging, so that the shelf life can be as is extended. So when we are talking about FPOs or the local entrepreneurs having this capability, not really from a processing perspective, I wanted to understand what is the current machinery available for access, and is there anything that can be done to reduce the cost or give out various quantity packaging?
Your question is there a gap in the offerings currently available? Yeah.
For vacuum packaging?
For vacuum packaging, which can be applied across commodities. We spoke specifically in the context of...
Yeah, the same vacuum packaging machine can be utilized for everything. It can be used. And moreover, in the farm fresh banana in TNAU, they are using a very simple thing. They are not having any vacuum packing machine and all. They are using a natural or normal vacuum machine, what we are using it in our home, as well as for our car and all. They are having an attachment. With that, they are making the vacuum packing. It's very simple. We can do it by small machine itself. We are just creating the vacuum.
So as I understand, the vacuum packing, there is no gap as such. It's a proven thing. Okay. So we are not listing that. Yeah. So now that we have, yeah.
Vacuum packaging, what is the machinery cost and what is the packaging cost? Vacuum packaging, what is the machinery cost?
Would you be able to say?
And what is the packaging cost?
It's a normal high density polyethylene bag, we can use it. And the packaging machine cost, it comes around 7 lakhs to 8 lakhs. But what they are using in that unit, they are using only 1 lakh capacity, 1 lakh machine. That can be fabricated and can be utilized. But machine, they are having it as 7 to 10 lakhs.
What is the cost of packaging? You are saying you are able to do it at 1 lakh. You have
Even
developed.
1 lakh we can do it.
You have a machine there.
We don't have it. The normal machine, what we are using it at home, that itself can be utilized for creating vacuum.
So understand that.
using it in
I
that
think this is
way.
very important.
Yeah.
Very important to understand.
Actually, I saw a machine being demonstrated right here in the morning.
How
It's a
much?
small vacuum
Small, just for one bag.
It's very small.
It seemed fairly simple and straightforward. I didn't ask the cost, of course.
But in one more thing is in vacuum packaging.
Packaging. What is the cost of variable cost of packaging?
So what he showed me, it had just a plastic bag. it probably won't cost more than a rupee or something. Yeah. So here is a little thought exercise. We have identified some areas. I'm sure it's not an exhaustive list. There'll be much more that we can come up with. But we also said that whatever solution we come up with for the capital cost of the equipment to be worthwhile, it must be something which should be used throughout the year, whereas any of these operations will last for only maybe a month, 40 days, that kind of thing. So whatever solutions we come up with should ideally be something which can be repurposed to do multiple things at different times. So today I configure the machine in one way, maybe put some attachments, etc. It works to do one function. And after 40, 45 days, I repurpose the machine, reconfigure the machine to do something else. And this way, maybe not 12 months in a year, but if I can utilize the machine for 8 to 10 months in a year, then I get a much better return on the money that is invested in the machine. So let us do from the list that we now have, we have how many items here? We have 9 items. Can we identify some common elements that go into these machines? For example, there is a need for vacuum. There is a need for hot air to be blown. There is a need for something to be compressed. I don't know, I'm just thinking aloud. Something to be crushed, something to be filtered, etc., etc. So grading and sorting is another important thing. Grading and sorting reminds me, there are a couple of my friends, actually 1 year junior to me from IIT Madras, they developed with a lot of effort a very sophisticated machine that sorts oranges using vision technology. So oranges come in different sizes. You can sort them by size, you can sort them by color. Some of them have little marks on them. Then they have to be sorted into a separate category because they get lesser value in the market, and so on. They do have a solution of some sort, but actually the most effective part of their solution is very commonsensical. They have a pair of, think of it like 2 sticks, which are nearly parallel but not parallel. And they're slightly tapering. So, and the narrower end is at a higher elevation than the broader end. And when you roll the oranges down it, depending upon the size of the orange, it falls at different places. And beneath it, there are different bins. So, although they use very complicated imaging and computer vision and everything, the real throughput they got through sorting in different sizes actually came from this. Then they had additional adjunct things which also diverted into different directions based on the color and other things. So not all solutions have to be very complex. Things can be simple. So can we put down some of the, from this list, what are the generic requirements that are common across these machines? In which case we can envision what a common platform would be like, and then some customized end modules will do for specific things. Just a thought exercise. We can spend maybe 5 minutes on it.
Dehydration of vegetables was one common element that we spoke about. So,
Okay.
when we are talking about processing at a village level, I think that will be again a very common ask.
Sure. So we need not limit to what has been listed here. This is only an illustration. This is not an exhaustive list. But we can maybe make a separate list of functional modules that are required in processing machines. One of which could be dehydration. Let us write down as it comes to our mind. Dehydration, then vacuum, blowing hot air would be something that is common across different operations.
majority of all the
Correct. So we have to list those functions.
only for specific thing.
And not all the functions will be used in all the crops, but what are the commonly used functions? I'm just trying to map it out. I'm trying to map it out and see what are the common things. Okay, vacuum packing, grading, okay. Cleaning, okay, cleaning.
Sanitation, I mean, whatever, sanitary practices, I mean, in terms of, yeah, microbial growth or whatever, prevention of that, those kind of things, so contamination.
Yeah. Hygienic, non-bacterial environment. That is, of course, a given because we're talking about food. Okay. Put packing and storage. Yeah. Okay. How is seed extracted? So is it filtering? How do we extract? Filtering? Okay. How is seed extracted? How is seed extracted? What is the operation? You showed a machine, but how does it work?
Seed extraction machines are not for food processing. That is for extracting the seeds from the fruit.
For sowing.
For sowing purpose.
For sowing. Okay. No, we are talking about food processing here. We are not talking about that's an agricultural operation. I agree. So how is it done? Is it done by filtration? How is it done? Yeah. So how is it done? Is it done by filtering or how is it done? What is the technology behind it?
That depends upon the crops.
You pick every individual seed out and keep, isn't it? So that is done by filtering, finally. Filtration. Okay.
That depends upon the crops, sir. That depends upon commodity.
Yeah, okay.
In case of amla, it needs splitting of the entire fruit, so we can remove this.
Yeah, things that are very peculiar and specific to one thing we are not now listing, but perhaps filtration must be listed.
So the design of the food processing equipment is very complex because the geometry and the shape of the material varies. So it is very difficult to design the material equipment for the biological material. Yeah, it varies with the shape, geometry, and other.
No, I agree with you entirely. Every single grain is different from every grain, leave alone even types of grains. So, correct. So that's where all the customization comes in.
Sir, pulper is a common thing for all the crop, majority. Pulper.
Yeah, filtration and pulping. Pulping and filtration. Okay, crushing. Crushing is there, yeah.
Say, they have a different machinery, sir. In all the food processing unit, the machinery manufacturers, they are having a crushing unit, then fine tuning, finisher is there. So they are having it in 3 different operations. So it should be in a combined one. Everything should be done in one pulping unit. That will be always better.
Why are they doing it in 3 stages? There must be some reason.
Yeah, they are doing it in different stages.
There must be a reason why they are doing it.
No, fine particles, that homogenization, they are doing it for that one. For some of the thing, we need only the juice, so they can be easily extracted. For something, we need a pulp. So for that pulp, they need to grind it very nicely. So in that case, they are using the pulp.
Okay.
Finisher. They are using that finisher. So it differs for different thing. So that has to be combined.
Fine.
Is there any machinery available useful for any other product which integrates all the functions? Any machinery available at present?
See, no machine will integrate all the functions, but generally machinery is designed in such a way that it is adaptable. For example, in engineering manufacturing, you would have a molding machine in general, but components of different shapes can be molded by just changing one die. Okay, I may have a stamping machine by just changing one tool. I can stamp out different parts. So the basic configuration of the machine is aligned to perform some function, but the specific output that we want will require us to change one part in it. I'm trying to apply that thinking to food processing equipment, that we have some generic machines, and in that we have some customized attachments which will be based on the particular crop and other things that is being processed. It may be a physical attachment, or like he said, process. For something you want 80 degrees Celsius, for something else you want 90 degrees Celsius, for something 60 degrees Celsius. You must be able to configure those things. So those are the specific configurations, customizations that we can do, but the fundamental machine does not change.
So the question here is there any other such type machine available at present in food processing?
In food processing, I am not aware, you must say. Okay, I am not aware. Yeah.
Sir, I would like to add one more point. I think there will be one element of thermal treatment, either heating or cooling, to remove the skin of the fruit, the peeling off layer. Should we have to add it anywhere?
So I had said hot air blowing, that has not been written.
So that, okay.
Huh. So heating, cooling would be basically done through that.
But we can write more generically heating.
Okay. Yeah. No, it's better to be more specific. We can always
Madam,
loosen it later.
Question? What is your question?
Size reduction unit. Cubes or shreds or pieces. For that we need one unit in the processing unit. Size reduction. So that
Okay.
is multifunctional.
Pressure is the size reducer.
Pardon, sir?
Pressure is the size reducer.
No. Pressure is different. Size reduction is we have to change the
See,
die.
we are right now talking about perishables mainly. We are talking about things like banana and tomato.
For almost all crop. Even banana, the raw banana, if you want to cut
Okay.
cubes in the form of cubes, you need a size reducer. If it is in the form of shred,
Okay.
then we have to have it.
So rather than use generic words like size reducer, she's technically correct, but it will be more easy to understand if you put slicer stroke shredder. Just put like that. It doesn't cover the universe. You can do dicing, many things, but I want to use words that are more readily understandable.
So in broader term, we can say size reduction. It depends, slicer, dicer.
I know. I'm trying to avoid a very generic word so that it's easy to understand for everybody. Yeah.
We may have a requirement for a mixing unit, which just makes things uniform, which is neither doing size reduction nor nothing, but maybe salt is added, so it has to be uniformly spread or whatever. I mean, some mixer.
Mixer. Blender. Call it blender. Yeah. Blender. We need a blender. Juicer, I guess, is covered in crushing, pulping. Yep.
Sir, I think we may require pasteurization or evaporator to concentrate that particular juices or puree, whatever we are preparing.
We had written somewhere that we should maintain it in hygienic condition, right? Where have you written? Okay, cleaning, decontamination. Yeah, there you write pasteurization in that itself, stroke pasteurization. Or put pasteurization in a separate point, because the nature of the machinery is very different. Yeah. Pasteurization is a separate point. Okay. Okay, so write pasteurize, stroke sterilize. Yeah. Pasteurize, sterilize.
So, here,
Yeah.
we might need a peeler for processing.
Okay. I think we'll include that in that slicer shredder point. Slicer, shredder, peeler. It's only the tool that will be different. The action will be
wondering, you are
The
listing
actuator will be similar. Okay.
Sir, you are listing the equipments for setting up a plant, or is there any gap?
No, we will have to now,
all these
we'll
machines
now
are-
come to a subset and see how you can create a machine that can do different functions and will be used for 10 months in a year. Because any of the other individual single function machines will only get used for 40 days in a year. So how can you build one machine which will be fully utilized for 10 months in a year at least? That's the idea.
Include blancher.
Pumps are required. Pumps, compressors.
Okay?
It's a
Pumps.
utility, but they will be required.
Yeah, but they come
Sir,
at a
if
lower
you
level.
go on
they're not
listing
direct
out,
function.
there are so many. You have to start from the boiler,
Because that will be like,
air compressor.
they are only actuated, they are not functions. They are not functions. So I think we'll stop with this.
Sir, if you go on listing the equipment, there are so many utility equipments are there, starting from the boiler, water softener.
Yeah. No, so
cooling
they are all
tower,
enablers.
so many
They are only enablers. They are not functions. I'm only writing the functions. Okay. So this is, I'm just opening it up because I'm coming from a very general manufacturing, production kind of background, not specifically to do with food, but I'm trying to see how things can be built. It doesn't have to be all, if there are 12 things written, one machine need not have all the 12. But by combining 4 or 5 of them, if I make a platform, can that be utilized profitably for 10 months in a year? That's the goal. So not all of them need to be in it. This is just for illustration.
Sir, for internal quality control, we need at least minimum laboratory with minimum equipments, laboratory to test, for example, what is the TSS content, what is the ascorbic acidity level, like that. So we have to have our own internal quality control. For that, we need a separate lab. Yes, sir.
Sir, we need an instrument that is retorting machine with high pressure. We can easily reach the high temperature, more than 100. And we have to reduce the temperature within short while. Within 10 or 20 minutes, we have to immediately cool down the product. Then we can achieve the good quality product. So in that case, if it is possible to make any kind of instrument. Yes. It's with high pressure and no, this machine can apply for any product, for packed product. Yeah.
And the machine that we think in a horticultural context. What would be one machine used for processing horticultural produce, which is there in a horticultural location, but which will be utilized fully for at least 10 months in a year? And what is the minimum set of functionalities with which we can configure such a machine? This is what I'm trying to do as a thought experiment. Because if there's a machine that's only going to be used for 40 days in a year, not only is it unproductive, I will require probably 10 different machines. I won't even have place to keep them.
So double jacketed kettle that will be used for concentrating the pulp. Any type of pulp we can do the concentration. So that for that we need an equipment called double jacketed kettle.
Okay.
Kettle. It is available in all processing unit. It is a multi-purpose.
Okay. Double jacket?
Double jacketed kettle. The purpose is, if you use a normal kettle, that may char the concentrated pulp. So to avoid that, in almost all processing unit, they'll be having a double jacketed kettle where we can get a good quality concentrated pulp. For any pulp, we can do the concentration.
No, that's good. It's a sort of specific implementation of one of these functions. So we'll not list that. It's a good implementation though.
So one general question for all of us is, in terms of TNAU, many products are already there. And each of them is doing a special function. But given few of those, can we think of integrating them into such a unit? So that's the real question for us.
So depends upon the requirement and the type of industry, then we can select these machineries and make it as an online processing machinery. So once you feed the product, fruit, you can get packed material outside. So in such a way, we have to integrate the machine. It's not single machine. It's a set of machine which is fit online.
Right.
So that is called online processing machinery. So like that we can skip for some products, we can skip one or two machineries. We will be having sequence of machineries to the product product to process.
So are such machines available now and being used?
Right now we don't. We have for turmeric, I think. Turmeric alone
We
we
have
have
a
at
set of
TNAU.
machineries for turmeric process.
Yes, sir.
Integrated value chain machinery for turmeric.
But not for other crops.
Is that machine operated throughout the year?
We have 4 equipments starting from the washer, boiler, dryer and polisher. So we can integrate all the 4 machineries.
Yes, sir.
But given the seasonality of the crop, is it used throughout the year or only part of the year?
So we have to perform all the 4 operations.
And it's done throughout the year?
To get a final end product.
I know, but is it done throughout the year or is it done for a few months?
Turmeric is
Season. It is a
seasonal only,
10-month
sir.
crop. Turmeric
It's a
is a
10-month
10-month
crop. It's a seasonal crop. So it will be useful for 3 months to 4 months.
3 to 4 months.
3 months.
So it is used for 3 to 4 months?
Yes, sir. Other time it will be kept ideal only.
Fine. So
Similarly, we have
my question is, can we redesign that turmeric machine in such a way that after the 3-4 months, it can be reconfigured for use with some other crops, maybe 4 more months?
Not possible, sir.
That
Not
prototype,
literally the same line
sir.
that you today have.
No, sir. That prototype is
only
totally
for
different, sir.
turmeric.
This process is totally different. So that turmeric processing is different. That needs only boiling. Yeah. Like that we can. That's why I told that at the beginning itself, depends upon the product what we are aiming. We can make an online.
So the
machinery.
4 steps involved are boiling,
Washing,
washing,
drying, polishing.
you're not grinding it?
Grading is the last step. After polishing, we can go for grading.
After
Sir, this is
polishing?
After polishing.
Okay, polishing and then grinding.
This is to make a turmeric.
Okay, make it turmeric.
After that, making powder is another process.
Okay.
Turmeric powder.
Tertiary processing.
Yes, sir.
What I am talking about is that secondary processing.
Fine.
Tertiary processing, it can be converted into powder. So the powder can be converted into curcumin.
Or it can be sold without...
That also we can integrate, sir. That also, because now this is on-farm. Wherever we want to just, taking to on-farm processing and all. So that making powder is a big unit. So all these on-farm products will be brought to the bigger unit. There the people will commercially doing powder manufacturing. After that, extracting curcumin alone. Like that we can do.
See, what I have seen, the reason I took this line of inquiry is that other than milk, all other perishables are seasonal. So milk plants like chiller and various other processing, they justify their investment because they are running throughout the year. But for all other crops, if the equipment is only used for 3 months in a year, then it becomes very difficult to justify the cost of an equipment. Unless, of course, it is very low cost, in which case we compromise on the quality and other things. One way out of this is if the equipment can be made multi-purpose and be used at different times. And the example we have for that is things like tractor in the agriculture. The tractor will be used for different purposes at different times of the year. Although all the operations are seasonal, it can be adapted to do different operations. That is the thinking I was coming at.
Sir, for instance, if you take a mango processing unit, it can be used only for 3 months. So after that, if you modified that layout, process layout or product layout, it can be converted, it can be used for other crops like tomato and other perishable commodities.
Correct.
So we have to plan in such a way that it can be used for multiple commodities.
And of course, that will be feasible if mango and tomatoes are grown in the same geographical region.
We can combine...
if they are in very different agroclimatic zones, then even if you engineer such a machine, it won't make sense. But if they are co-located, then that's a very good thing to do. Yes. How are we doing on time? Are we out of time? Final remarks. Yeah.
Yeah, no, so I think what we've essentially done is what is done for a chemical plant process design. I mean, you use list set of unit operations and then now you have to assemble it as part of process, as he was saying. And our additional constraint is we want some unit operations to be operational for some period and some other unit operationals to be, operational other period. So we will have to, based on like what was said, that we need to see what could be, let's say, 3-4 crops for which we want to target this. Then we can list what we needed. Scale is something which also will have to be specified, and then we can think of 4 different configurations in which this process can operate.
This was just meant to open a line of thought. It's not, obviously in a 1 hour session we cannot come to some conclusive firm designs. But I think it was very educative for me, and I hope all of you had something to learn from this. Thank you.
Professor Ashok, would you like to add something before we wind up for the day?
I think now there is a tour of IITM Research Park. It's a little getting late, so it's good to go. Come back in about an hour, 15 minutes, and we'll have a dinner and probably spend some time together. This IITM Research Park, in case you people do not know, this is just outside IIT Madras on a land leased from Tamil Nadu state government. This park is like a startup. This was not funded by anybody. This is not funded by government or any other entity. Seed capital was put by government and some alumni. But after that, we borrowed money from bank. We borrowed 400 crore rupees from banks. We have actually, over the last 10 years, paid them back with interest. We are debt-free. We don't get 1 rupee from government. We don't get 1 rupee from IIT. We do not take grants for operation for this park from any industry. It is a self-sufficient, generate 50 to 60 crore rupees cash profit every year. So it has been done like a startup. Again, looked impossible, like many other things that we are talking about. But we actually were able to manage to do it, and that's a strength. At the same time, we incubate companies out here. Over the last 12 years, we have incubated 300 companies. The value of these companies together is 40,000 crore rupees. The value of the companies incubated here is 40,000 crore rupees. It's unbelievable. We have hardly put a few crore rupees into this, and the value is 40,000 crore rupees. In a diluted form, we own 1% shares in this company, which basically means that we ourselves have about 300-400 crore rupees worth of assets, and we keep on cashing this periodically, and we use all that to carry out the operations. As I told you, we do not take any money. We don't come under the control of the government. It's an independent Section 8 company, non-8 profit company, and run by its board of governors. Of course, IITM appoints the board of governors, so in that sense, it has a controlling interest, but otherwise independent of this. So I suggest, since it's getting a little late, we don't want you to 1 hour, 15 minutes, quickly go around. We'll come back here, have a dinner, a little more informal interaction, and then we'll meet tomorrow. Thank you. Thank you for this wonderful discussion. This is the right approach, but I think we need to pick up a few the items, and we have to start looking at how do we really go about designing the machinery. Tomato is one, but tomato also, a lot of processing is possible. But a lot of these things that you talk about, the common things, is the key thing to make things work. Thank you. Thank all three of you.